All right, so today we're going to be talking about inscribed and circumscribed polygons. If you're following along in the same book, it is in 10.7. So your learning goals, you will be able to recognize inscribed and circumscribed polygons, apply the relationship between opposite angles of an inscribed quadrilateral, and identify the characteristics of an inscribed parallelogram. All right, so let's talk about inscribed and circumscribed polygons. So if we say triangle ABC is inscribed in circle O, this is what the diagram would look like. So the triangle is inside, so inscribed means inside. More specifically, a polygon that is inscribed in a circle if all of its vertices lie on the circle. So here we've got a vertex, here we have a vertex, here we have a vertex. Now if I said polygon PQRST is circumscribed about circle F, that means the polygon is on the outside, the circle is on the inside. And for that, a polygon is circumscribed about a circle if each of its sides, so every single side has to be tangent to the circle, so that means it has to be touching at exactly one point. So now keep in mind these statements could be written differently but have the same meaning, depending on which figure is inscribed versus circumscribed. So you're going to be looking for the words about versus in. Like you could say that the triangle is inscribed in the circle, or you could say that the circle is circumscribed about the triangle. They mean the same thing, so just be very, very careful when you're reading these problems. Some more definitions for you. So the center of a circle is circumscribed about a polygon. That center is called the circumcenter of the polygon. So if the circle's on the outside, the circumcenter is the center of the polygon, the circumcenter. Okay, the center of a circle inscribed in a polygon is the incenter of the polygon. So basically these points are still the centers of these figures, is basically what that is. If the circle's on the outside, it's the circumcenter. If it's on the circle's on the inside, it's the incenter. So that's your little kind of clue to help you remember that. All right, some theorems about inscribed quadrilaterals, which are going to be very useful. So if a quadrilateral is inscribed in a circle, its opposite angles are supplementary. So that would mean that A and C, so angle A plus angle C, would have to equal 180, and angle D plus angle B would also have to equal 180. Theorem 94 says if a parallelogram is inscribed in a circle, it must be a rectangle. So that's important. You might only know that it's a parallelogram, but you'll have to know that if it's inscribed, it is a rectangle. And some theorems to go along with that, or some parts to go along with that. Your diagonals BD and AD, those are going to be diameters of the circle. O is in the center of the circle, so where those diagonals cross is the center of the circle. And then, of course, OB, OA, OC, OD, those are all radii. And then, of course, AB squared, these are right angles, so AB squared plus BD squared would equal AD squared. You get the idea. So here's some practice. Let's start with a proof. We are given circle O, and we need to prove that angle Q is congruent to angle PST. So we'll start with our given. And then we can say that angle Q is supplementary to angle RSP. And you can tell from the diagram that all its vertices are on the circle. So we don't need to state that because it's given us in the diagram. So if a quadrilateral is inscribed in a circle, its opposite angles are supplementary. So we know that. Then we can say angle RSP is supplementary to angle PST, because two angles forming a straight line are supplementary. And then finally, you could say that angle Q is congruent to angle PST, because two angles supplementary to the same angle are congruent. So simple four-step proof, but just to kind of reinforce this idea here. All right, last practice problem. We need to find the measure of arc ABC. So they give you three letters, so we're talking about from here all the way around to here, and they're saying measure. So that means our answer is in degrees. Answer in degrees. All right, if they were talking about length, that would be different. And we're given the measure of angle A, angle B, and angle C. Now, because opposite angles, we've got a quadrilateral inscribed in a circle. And because opposite angles are supplementary, we're going to take 10x minus 8 plus 8x minus 10. set it equal to 180. Go through the steps. You end up with x equaling 11. So now we're going to plug 11 in, because if we find out what this is, we know that those two have to be supplementary. So I can take 180 minus this to find the angle D, which, if you look, intercepts that arc. So 180 minus 6 times 11 plus 2. So angle D equals 112 degrees. And if you remember, your angle will equal half. So the angle measure, the measure of the angle, equal, when we're talking about an inscribed angle, equals half the measure of the arc. All right, so that would mean that twice the angle measure would equal, would equal the arc measure, which is what we're trying to find. So that gives us an arc measure of 224, and that's it. Enjoy the rest of your weekend, guys, and we are almost done with this unit, just a few more sections. Have a good one.